Hello, everybody. Thank you for attending this Manning on Twitch session. I am Cătălin Tudose. I am the author of the book JUnit in Action, 3rd edition, currently under print at Manning. A few things to introduce myself. I'm in the IT industry for more than 20 years, and more than 15 of them have been dedicated to Java and to the technologies around it. I participated in networking and financial projects, and for 6 years I am acting as Java and web technologies expert at Luxoft Romania, the employer that I'm working for since 2003 in Bucharest. The topic of our session is BDD, or Behavior-Driven Development, with JUnit 5 and Cucumber. I'm excited to be here with you, so let's get started. The objectives of our session. You, the attendees, will find out about the fundamentals of behavior-driven development. You will learn about the basics of Cucumber and the basics of developing a Java behavior-driven development application with Cucumber. Who is the target of this session? Who should attend with good results? If you are a developer who is new to BDD, that's fine. It is for you. If you are a developer that has understood some of BDD and want to work with Cucumber, yes, it is for you. You're good to go. Also, if you're a tester who need to automate a part of the activity, also it is for you. We start from the idea of test-driven development. If you are familiar with this test-driven development idea, you know that it is based on a three-step cycle. You test, you write some test that is first supposed to fail. Then you code, meaning you should write that code that will make that test pass. Then you eventually refactor, so meaning that you improve the quality of your code while keeping its external behavior to be the same. So test-driven development is based on this three-step approach: test, code, refactor. This is a good thing, but it also comes with some limitations and shortcomings. First, tests are tightly coupled to the implementation. So you have to understand well what you need to implement and what it is there. And you will write a test to check some method of yours or some class. So it is a tightly coupling between the tests and the code. Then you are focusing on the method or class that is tested. As we are saying, you're writing that test for the method, for the class, and the business goals are neglected. In many cases, you do not understand what the software is supposed to do, which is the business logic, which business needs that software needs to address. So while TDD is making sure that you are doing the things right, behavior-driven development will come with a step forward and will say, we would like not only to do the things right, but also to do the right thing, to make sure that what we are doing is really useful for the end user of the application. So if we would like to formally answer to the question, what is BDD? BDD is a methodology for developing IT solutions that are directly satisfying the business requirements. So you keep in mind the business requirements, which business requirements you will need to satisfy, and you are developing your software accordingly. So when you are developing your software, you are going to focus on adding business value to the application. And you are interested in facilitating the communication between the business analyst and the developer. And this is also something that BDD provides. It facilitates the communication between the business analyst, the one that knows what needs to be done, how the software should work, and the developer the one that effectively implements it. As we're saying previously, we are making sure that we are doing the right thing. We are making sure that we are doing something that really addresses the business needs. And probably you are familiar with such a describing requirement. This is something usual in incrementing style development, in Agile, for example, when you would like to describe the requirements using the keywords as a, I want to, so that. And we are providing here the description of two requirements that are related to what we're going to present immediately. As a usual customer, I want to get an economy credit offer so that I can apply for it. So this is what you're expecting. You are taking a role of the usual customer, you are doing some action, get an economy credit offer, and you would like to have some consequence to apply for it. And the second requirement describing, as a VIP customer, I want to get a business credit offer so that I can apply for it. And as we were saying, the keywords are as a, I want to, so that. And we are providing here the business logic for two things that we are going to demonstrate in our application. We presume that we have some bank that is providing credit offers, and there are two types of credit offers, economy and business, and that there are two types of customers, usual or regular customers and VIP customers. And you say, I would like to add a customer to a credit offer. Is the credit offer economy? If it is economy, yes, you will always approve the request as you see here. If the customer, if the credit offer is not economy, meaning it is business, you have to ask yourself, is the customer VIP? And you are going to add the customer to the credit offer. You are going to approve the request only if the customer is VIP. Otherwise, the request is rejected. And we have the policy that is established by the bank to remove a customer from the credit offer. And the policy says, is the customer VIP? If he's a VIP or she's a VIP, we reject the request. We will not allow to remove that customer from a credit offer once it has been granted. If the customer is not VIP, you are going to approve the request and remove the customer from the credit offer. And we are showing how we make the automated acceptance tests. You see here a first taste of the way behavior-driven development works. We say we have to implement the feature of the customer's policy, meaning exactly what we were showing a few seconds previously. So we have to implement the customer policy regarding how they interact with the credit offers. Say here, the bank follows a policy of adding and removing customers depending on the credit offer type and on the customer type. And we have one scenario out of 4 scenarios, because we have 2 types of credit offers, 2 types of customers. 2 multiplied by 2 will mean 4 possible scenarios. And the scenario is for economy credit offer and usual customer. And we say, given there is an economy credit offer, when we have a usual customer, then you can add and remove him from an economy credit offer. And this is the feature that we would like to implement. You see these keywords, given, when, then. These are parts of the test and are keywords of the behavior-driven development idea. The given keyword will say we have something that is provided. We have some preconditions. When means that we are doing some action. Then we are expecting a consequence. If you would like to make some analogy, think about how an application will act when you are pressing a button. Given that I have that window open in my application, when I press that button, then I am expecting these statistics to be provided. This is a scenario that is showing exactly what you are expecting from the application, So this is a good taste of behavior-driven development. It shows how you are interacting with the application and how you have the business requirements in your mind. And this is the idea of developing behavior-driven. You keep the business requirements in your mind, and you keep in your mind the way you as a user should interact with the application. So these are the parts of the test, the given, when, then parts that we are going to encounter during our demonstration. Of course, when we are making the step between test-driven development and behavior-driven development, and we're saying that we would like not only to do the things right, but we would like also to do the right thing, we would like not to decrease the quality of our tests. So if we have some tests at some quality, and if we adopt this new idea of behavior-driven development, of course, we recognize its advantages, but we would like to keep the same test quality. And one of the metrics that addresses the test quality is the code coverage, defined as a measure to describe the degree to which the source code of a program is executed when a particular test or a particular test suite is run. So you have a suite of tests, you would like to execute them. You have some code coverage, meaning that the tests are executing some part of your code, some percentage of your code. You may be happy with this code coverage. You are working TDD, or you have inherited some application that is already tested. You would like to make the step to BDD, but you would like to keep at least the same quality of the tests. Besides the fact that you are going to be business driven, you would like to keep the same quality of the tests, and as part of the qualities of the test, there is the code coverage. You may ask yourself which percentage of code coverage is feasible. From my experience, I can tell you that in most cases, a code coverage of 80% is part of the definition of done. So you are expected, in order that your product to be shipped, to have at least 80% of code coverage. Can we do more? Sure, we may try at least 90% of the code coverage is much better, but I can tell you that the effort of moving between 80% and 90% is really significant. These 10% may require a good effort from your side as a developer, and sometimes you have to do some artifices in order to achieve such a code coverage. 100%, is this feasible? Usually it is not feasible, but you should strive to get as close as possible, because working with tests, working TDD, BDD has provided big advantages. and you would like to have some safety that the code that you are running, the code that you have written for your application is really doing both the things right and the right things. And if you get closer to 100%, then you will have more safely. Just to tell you as an aside now, it is not among the topics of today, but it deserves to be mentioned. Just even if you arrive to 100% code coverage, it does not mean that your code works perfectly. Why? Because you do not have a certainty about the quality of your tests. And here, if you would like to be sure that your tests are good quality besides the code coverage, I was saying that code coverage is one metric for providing the test quality. So if you would like to have safety about the quality of your tests, you should go by mutating testing. This means that you run a suite of tests, and there is a tool that will modify a little. For example, in Java, the bytecode will run the tests again, and it will expect this test to fail, because if a test is well written, then if you modify the code a little here and there, you're expecting this test to fail. And we are moving to our practical demonstration. We have taken this time in order to introduce the idea of behavior-driven development, the ideas of what code coverage and what code coverage is and why it is important, why we should care about it. And we are saying that we have some application that is working with credit offers and with customers. And you see here that we have a customer that is described by the name and by the fact that he or she is VIP or not. A credit offer has a list of customers that have been assigned to it, and you may add a customer or remove a customer from this credit offer. But you remember that we have two types of credit offers. So we have economy credit offer. So we say here, according to the business logic, you remember those schemas that we have shown. When you would like to add a customer to the economy credit offer, no problem. You will always allow to add that customer. If you would like to remove the customer from an economy credit offer, then you can remove him or her only if he or she is not a VIP. Otherwise, once you have assigned that customer to the credit offer, you cannot remove a VIP any longer. And we have the business credit offer with the same policy. Add customer and remove customer. So the business credit offer allows only VIP customers to be added to it. If you would like to remove a VIP customer, that customer cannot be removed any longer. So once he or she is there, cannot be removed. So this is the policy that we have provided. We have shown those logical schemas. And now we take a look at how our tests are written and how they work. You see here, this is a test called bank test, and we have 1, 2, 3, 4 tests because we have two types of credit offers and two types of customers, and 2 multiplied by 2 equals 4. And this is an application that could have been developed TDD or test-driven development way. So you have economy credit offer, usual customer. And here we have our test that is doing something and is expecting something. We have an economy credit offer and a VIP customer. And we have some actions into the test and we have some expectations. And the same for business credit offer and usual customer. The same for business credit offer and VIP customer. Are these tests useful? Of course, they are very useful, but they have some limitations. You see here that the tests are not telling you what you are expected to get, which is the expected behavior. You say here, I'm testing an economy credit offer with a usual customer, but what for? Why? Why am I testing and what am I expecting? The same here, test economy credit offer, VIP customer, but we have no idea about what is expected. We are testing and we are expecting some output. And we should say here that in the early days of BDD that has been invented by Dan North in the early 2000s, the developers of his projects decided to write here a test with a more significant and longer name saying should expect this and that. And the test, the name of the method was speaking by itself, saying I'm expecting something and I would like to communicate this to you so that you understand why you are doing this and what you're expecting. And Dan North and his team, when they were working this way, they have understood, they have discovered that this was something that was really simplifying their life. It was providing much better understanding of what those tests were supposed to do. And Dan North named at that time the way they were working not TDD, no TDD any longer, but moved to behavior-driven development. And this is the beginning of the test-driven, of the behavior-driven development. But you see here, coming back to our application, we see that we have 4 tests that are saying what we are testing, but may not say what we are expecting. Let's run this test suite. I'm right clicking here and I'm going to run it using code coverage because this is important. I was saying that we would like to move to BDD approach, but we would like at the same time to keep in mind that we are not affecting one of the important test quality metrics, meaning the code coverage. And we see here that we have 100% code coverage. This is really cool. Just to let you know that also the structure of the code is allowing us, the code is testable. So the code exposes itself and we were able to achieve this 100% code coverage. So this was the way TDD could have worked, or this is something that you may receive as an already existing application and you have to deal with it. You have to understand what is going on and you have to understand the business logic in order to maintain the application or in order to add new features. And we would like to show that we can do better if we approach the idea of behavior-driven development. And we move here to the second application that is called bank application BDD first step, because we would like to demonstrate how we are doing our work both with JUnit 5, only with JUnit 5. So this would be a first step. And then we are going to move to the cucumber approach, which is another step. Let's see here that we have exactly the same application with credit offers and with customers. And if we look here, well, we see that the structure of the code, of the test code, is very different to what we were providing here at the beginning. You see here we had 4 tests. Of course, they were all concentrated within one single class. But if we go here, we see that we have a hierarchy of tests. And we are taking advantage of the benefits and of the new features provided by JUnit 5 in order to build something, I would say, really beautiful. We have a test, and inside it we have another test. And inside it we have another test class. Of course, class inside class, meaning nested classes or inner classes, exists from the beginnings of Java. But JUnit 5 comes with this idea of nested tests, and we are using here this nested annotation, which is a JUnit 5 annotation that is provided by the version 5 of the testing framework. So we have here a test class inside another test class, and we are building a hierarchy of tests starting from the top, from this bank test. And you may ask yourself, when may you consider to use this hierarchy of tests? The answer is similar to the question, when should I consider to have a nested or an inner class? Not nested inner test necessarily, but a nested or inner class in Java. I was saying that X exists from the early days of Java. When two classes are very tightly coupled, then you may consider putting them one inside the other, so a nested class. Here, you see that we are having an economy credit offer, and inside it we have a usual customer. Here we have a tightly coupling. So the usual customer and the VIP customer are tightly coupled to the economy credit offer in the sense that we are testing them together. So it really makes sense that you put a test inside another one and keep them nested. The same here, a little lower, we have nested business credit offer test, and we have usual customer, this time with in relation with the business credit offer, and VIP customer, this time in relation to the business credit offer. And if you take a look here, you see also we are using this display name annotation. The same here, display name annotation. The same here, display name annotation. This is also a JUnit 5 annotation. It allows us to show the test in a nice way. I was saying that in the early days of BDD, Dan Norse was using those long method names. That is not always convenient, but we can provide this meta information instead of putting here, for example, a long name, saying exactly in plain English, it's plain English, what the expectations are. Then you can add and remove him from an economy credit offer when we have a usual customer. So you see here that we are able to read in plain English the entire scenario. And of course, you are recognizing here the given, when, then keywords. The test, the then part is including the assertions, meaning the verifications, what is expecting, and we are using here this assert all method, which is also specific to JUnit 5. Which is the advantage of this assert all versus putting this assert equals assert true one under the other? If we look here, this is what we were doing in our first approach. The big advantage is that no matter if, let's presume, this test fails, the tests that are following it are still executed. So this was not happening here. If this test fails, the subsequent one are no longer executed. So this assert all is taking care of executing all the tests, no matter if one or more of them are failing. So you see, this is a really new way of writing tests. And we're saying that we are making a first step towards behavior-driven development. And let's run the tests. Let's see how they look like. You see that the way we have organized our tests hierarchically and the way we have annotated them with that display name annotation, now you are able to read the behavior in plain English. Let's read here. Given there is an economy credit offer, when we have a VIP customer, then you can add him but cannot remove him from an economy credit offer. Given there is a business credit offer, when we have a usual customer, then you cannot add or remove him from a business credit offer. This is plain English. And if we go back here and rerun the initial test, you see it is much less significant. Say test business credit offer usual customer, but what for? Which are the expectations? While here you are reading the scenario. And remember, we have done this using simply and only JUnit 5 and its capabilities. Of course, we would like to make sure that we have kept the quality of our tests. So if we right click and run with coverage, we see here that we have remained at the level of 100% code coverage. Besides the fact that these tests are looking much nicer, they are readable, they are significant, they tell how the business works. We are in business, in behavior driven development, they tell how the business works in plain English. Here, looking at these ones, everyone can understand the fact how the application should work. Everyone should understand what's expected. Even if you are a less technical person, then you will immediately understand what's expected from here because we have the business in our mind. And we would like to make the next step to using Cucumber. What is Cucumber? Cucumber is a BDD testing framework. It works in conjunction with Java, not only, but of course we are doing it, we are using it for Java. And to introduce Cucumber, what do you need to do in order to start using Cucumber? You need to add some dependencies here to your pom.xml file, and you will be able to write something of this kind. You see here a whole feature with 1, 2, 3, and 4 scenarios, the 4 scenarios that we have previously introduced. 2 types of credit offers multiplied by 2 types of customers. 2 multiplied by 2 equals 4. You see that you are reading everything in plain English. The keywords are feature, scenario, given, when, then, the ones that we are already familiar with. We are able to add here some plugin in order to work easier with Cucumber. Of course, I have already added it on my machine. And there is also Gherkin plugin that is important. You may ask yourself, what is Gherkin? We haven't introduced Gherkin. Gherkin is the language itself. So if the behavior-driven development tool is Cucumber, the language that is describing these scenarios is Gherkin. So Cucumber is the testing framework, while Gherkin is the language itself. Okay, you have this as input. Who should build this? Generally, this should be built by the business analyst, the one that knows how the business is working. And the business analyst will come and say, I would like to do this and that. I'm expecting you, the developer, to implement this and that, but not verbal communication, because verbal communication is sometimes dangerous because it allows information to be lost, misunderstood. Here we are working on scenarios, we are working on examples, and this is what we call acceptance tests. Is your feature ready? It is ready if it will make this acceptance test pass. So this is something that the business analyst may compose. Say, I'm expecting you to do this and that. Oh, what are we going to do with these ones? You are receiving them and you have to transpose them in code. And here we are looking at how our new tests look like. You see, we still have some annotations. What it is very important to mention here is that these given, when, then annotations are Cucumber annotations. They are not JUnit 5 annotations. So you see here that we have imported here only the Cucumber annotations, given, when, then, from the Cucumber packages. And you are still able to read, given there is an economy credit offer. When we have a usual customer, then you can add and remove him from an economy credit offer. So you will be able to read them in plain English. What's this method, for example? If it is annotated given there is an economy credit offer, it means that it corresponds to this step. So using Cucumber and Gherkin, you will be able to create a structure of methods that are following these scenarios. So whenever you would like to execute this test, say I would like to execute this scenario, and this scenario consists of this, and this step. It means that the Cucumber engine will execute this method and this method, then this method, and this then method will contain the verifications. You may ask yourself, which is the difference from these annotations given, when, and then? And the answer is that purely technical, there is no difference between them. For Cucumber, when executing these methods, they are simply some methods, some steps that they have to execute, and no difference. The difference between them is at the level of human understanding and at the level of human significance, because you will read given, you will understand, like here, that it is a precondition, something is provided. You will read when, you will understand that something is happening, some action is taken. You will read then, you will understand that you're expecting some consequences. So this is the structure of the Cucumber tests. You see that we have only method after method annotated with given, when, then, the Cucumber annotations. And if we look here, you see I'm going back to the JUnit 5 hierarchical approach. We do not have tests inside other tests. Here we have 100 and let's say 19 lines of code. Here we have only 85 lines of code. So using Cucumber, you may also gain not only clarity here, but you may also gain some amount of code. Where does this come from? For example, here we have usual customer, VIP customer, this class, and this class inside business credit offer and here we initialize these fields. And we have VIP customer and usual customer. Also for economy credit offer, we make some similar initializations here. So you see that some code that needed to be duplicated here using the JUnit 5 hierarchical solution with nested tests is no longer true here, because any code duplication has been removed. We have only one passenger Mike and only one passenger John. We don't make any duplication. What do we need to have in order to run this test? So we need to have this special Cucumber test class. This class should be empty. Step definition is in separate class, meaning here. And we have here some annotation run with Cucumber class. We have some options, meaning how to display the results. These are the names of the methods which are camel case. You see here there is an economy credit offer in camel case. And we are telling where to look for the feature file on the class path in the features folder. So let's run this Cucumber test. So you see here all green, and we are able to read scenario given when then. Scenario given when then. Plain English, and even easier than we are doing for our previous approach. Let's check that we are keeping the same code coverage. 100%, so we haven't lost anything from what it was tested by moving to Cucumber. Let's make some more provide some more details about how these things are working. I'm going here to run edit configurations. And I will show that we are able to run directly such a feature file. So not a Java test, but such a feature file, a file of this kind here. If we can do small configurations, so have here customer policy, main class, this is the main class from Cucumber, glue here. I need to introduce this com.manning.bank application, com.manning.bank application. Name of this package comes here. And the feature is exactly this feature file. We save this configuration and let's try to run exactly this customer policy. So you see here that we are able to run exactly that feature file without details. So you will be able to quickly see, okay, we ran 4 scenarios, 12 steps. Everything is fine. What else should be this good for? Should be good for somebody that is a less technical person, would like not to work with Java code, and would like to run directly this feature file quick and without too much technical trouble. And it is also good if you would like to generate a skeleton of your tests. So you may ask yourself, how much should it take if I have to write this given there is an economic credit offer with this caret here and with dollar sign here, and maybe if I'm making a mistake and losing something. Let's show how this can be automatically generated. Let's presume that we have forgotten to add this given there is an economic credit offer method, or maybe even this class is empty and we are running this test, this feature file, just the way we're doing. It says here, okay, we are failing. It says you can implement missing steps because we have removed that step, and it is providing exactly this name of the method. And you can just take it here with the annotation with the name and put it here, then write the Java code that corresponds to this step. You see here that we have been provided this there is an economic credit offer camel case method. We have here the possibility, let's remove this snippet, camel case, rerun this, and you see here we have another name of the method with underscores. I personally prefer this camel case. So when I created my test, I have this one enabled. So we keep this policy. If you will ask yourself which policy is better, I would say, even if I prefer the camel case, I cannot say something is better. I will just recommend that you keep something consistent and uniform. So if you use camel case, keep using camel case. If you use underscore, keep using underscores. Maybe this should be some policy to be established at the level of the project. I have undone this method removal, and if we run here again this cucumber test, we see here that all tests are running fine. Code coverage is 100%. So we have demonstrated how to work behavior-driven development with the help of cucumber and gherkin. This was the third way our application was tested. We remind you that for all three versions, we have the same base code here. Nothing has changed. We are just trying to change the ways testing is made. And we remind that we started with this way of writing tests with 4 methods here that are not very significant from the point of view of telling what they are doing, what they are expecting. And this is how this test look like. We moved a step forward by introducing the capabilities of JUnit 5 with nested test and the display name annotation, and we received something really nicer. But we said we could do better uh, with Cucumber, so that we have this scenarios feature concentrated in one single place. And this is the way we are writing our code, which is also shorter than in the case of a pure JUnit 5 solution, and easier to follow. Let's have another look here. Say scenario, immediately read here, or here you may read in plain English. So this concludes our demonstration. We have passed the same application starting from being unit tested, TDD, to some simulated behavior-driven development with JUnit 5, and then we moved to the work with Cucumber and Gherkin, which is pure BDD. I think you have good arguments to adopt Cucumber or some other behavior-driven development tool in your project. So this was the presentation and the demonstrations from my side. I have concluded here. I'm looking here to the chat if we receive some questions. Otherwise, I would say that we should be done. Okay, if there are no questions, I think we can conclude our session here. Thanks for watching, and I hope you enjoyed it and that it will be useful for your future activity. Thank you, and see you in some other session. Bye bye.